In example 2, we want to carry out essentially the same operations, but with two new functions, h and k. In part A, we first want to take x minus 8 plus 7x squared. In this case, nothing to distribute through, so we can simply look at combining like terms, where actually in this case there are no like terms to combine. So we simply end up with the resulting expression 7x squared plus x minus 8. In part B, we're taking the difference of those two functions. In this case, there's still really nothing to distribute because that negative only applies to a single term. So we end up with negative 7x squared plus x minus 8. In part C, we want to take the product of these two functions. So we'll take x minus 8 times that quantity 7x squared. Keep in mind we can reorder multiplication, which tells us we can rewrite this as 7x squared times that quantity x minus 8. If that helps us to see a little bit better that we need to distribute that expression 7x squared through those parentheses. This will give us a result of 7x cubed minus 56x. And in parts A through C, we can state that our domain would be all real numbers, or negative infinity to infinity, since h and k have no restricted values, and none of our resulting functions have any restricted values. In part D, we want to take the quotient of these two functions, meaning we'll take x minus 8 divided by 7x squared. Here there's nothing to reduce or simplify, but we do have a rational function, meaning we can't have that denominator set equal to 0, which tells us that x cannot be equal to 0. Or if we wanted to state that domain in interval notation, we could state that the domain is negative infinity to 0, union 0 to positive infinity.